The reference emission line panels are shown at the bottom of the analysis display area. The graphs in these panels can be used to confirm the identification results generated by the algorithm. They display the currently displayed spectrum in the regions of the spectrum corresponding to the reference emission lines used by the identification algorithm. So in this instance, zinc is the element to view, and the current spectrum is from x equals 4, y equals 4, and spectrum number 1. So these are the regions of this spectrum corresponding to the reference emission lines for zinc. Again, if the element or spectrum number to map are changed, then these panels are updated accordingly. So if we change the spectrum number to map, we can see how the panels are updated, and if we change the element to say magnesium, we can see again how they're updated to the regions corresponding now to the magnesium reference emission lines. Each reference emission line panel is titled with the element, ionization state, and wavelength of the reference emission line that it represents. The wavelength position of the reference emission line is marked with a vertical red line. Just see it here. Libsoft attempts to find a peak in the spectrum in a region either side of the characteristic peak that fulfills the conditions set in the configuration window, the details of which are described in a separate video. The region shaded in grey in the reference emission line panel, which you can probably just about see here, is defined by the peak match tolerance parameter, i.e. it's the range of wavelengths centred on the reference emission line wavelength in which the analysis software searches for a candidate peak. The peak window parameter specifies the interval either side of the candidate peak in which it must be a maximum to be defined as a peak. This is to eliminate candidate peaks at the edge of the defined search region which are not true maxima. A purple dot is used to mark the location of the peak if one is found. See the purple dot there. Libsoft also identifies the minima in a region either side of the identified peak. This region is defined by the reference window width parameter. The minima identified are marked with green dots here and here. The intensities of the identified peak maximum and these minima and their wavelengths are used by Libsoft to determine the validity of each peak, i.e. whether a sufficiently significant and distinct peak is present at the expected location to suggest the presence of the element. The peak is assessed in terms of its absolute intensity, its signal to baseline ratio, width, and how closely the wavelength of the maximum matches that of the known characteristic peak for the currently selected element. If all of these values are within the limit specified by the analysis configuration, then the peak is deemed to be valid and is marked as such using a green indicator at the bottom of the panel. So here. If a peak is deemed to be invalid, it is marked as such using a red indicator instead of the green. Each of the 5 peak panels also includes various additional diagnostic data. For example, a horizontal purple line indicates the minimum peak intensity specified in the analysis configuration. You can see that line here. The intensity of the maximum and the signal to baseline ratio either side of the maximum are indicated at the bottom of each panel, together with the calculated peak width. So intensity, signal to baseline ratio at the left-hand side of the peak, the ratio at the right-hand side of the peak, and the peak width. From these values, it is generally possible to identify why a peak has been determined by Libsoft to be either valid or invalid. Occasionally, a slight wavelength offset may be seen between the peaks in the spectrum and the marked characteristic peaks for the elements to be identified. This could be due to a small drift or offset in the spectrometer calibration. If this is the case, a linear wavelength shift can be applied to the loaded spectra using the wavelength shift parameter on the configuration screen. This parameter here currently set to 0. There are up to 10 characteristic peaks for each element in the libsoft database, 5 primary and 5 secondary peaks. To display additional peaks, select the Next button at the bottom right-hand side of the screen. This will cause the displayed peaks to scroll to the left and any additional peaks to be displayed on the right. The Previous button can be used to scroll the peaks back to the right. Secondary peaks are identified by the addition of an asterisk in the title, so reference peak 6 has an asterisk to indicate that it's a secondary peak. Secondary peaks are not generally used in the identification process, but can be useful in certain scenarios to confirm the presence or absence of an element in the sample. They are, however, used for certain elements whose primary peaks are known to be subject to self-reversal. In this case, due to self-reversal, the primary peaks could be falsely identified as being invalid. Hence, if the initial analysis is inconclusive using the primary peaks, the analysis is repeated using the secondary peaks.